computer. Okay, so yeah, so we were saying in our review here that read is to read to a file. What is this FD? Is a file descriptor. Who gives you a file descriptor? How do you get a file descriptor? What command?
With dupe.
That's true. Dupe could give you one. What else could? What initiates the first file? Like, if you remember, a file descriptor is on a file. Let's say you want to open a certain file. How are you gonna? I mean, I just told you the answer there. What C command will let you access a file?
Open.
Open gives you a file descriptor. Open provides you the file descriptor. Read uses that file descriptor. What's the buffer is what?
What it reads into.
Exactly. And the count is what?
How much it reads.
Well, now explain exactly what the count is. What does that mean? If I read it, count is going to change if I read 1 or if I read 5. I mean, I don't know how much I'm reading. I'm reading from a file. I don't know how big the file is.
It will read up until the count, right?
That's right. So what determines the size of the count? In other words, when I make the count, it's going to be a number. It's going to be like 10. Well, how do I know what number to make it?
I mean, we want to know roughly what the size of our file is.
No, assuming you don't know anything about the size of the file. But, well, the buffer here. If I made a buffer of 10 bytes, then my count could be 10, for example. Depends on, this is like essentially telling me, preventing me from overwriting my buffer. So the size of the count is going to be equal to the size of the buffer. More or less. It could be a little bit smaller than the buffer, but it's certainly not going to be bigger than the buffer. Presumably, it's the same size as the buffer. In other words, it is telling me what's the size. This is just a pointer. I have no idea what thing it's pointing to. This tells me the length of the thing that I'm pointing to. Okay. And here we do that. We have a buffer of 256, and I made this size 255 because I want to add in my own null at the end. So therefore, I don't want it to write into the full size of the buffer. That's just because I'm trying to print it. Okay, so this is just printing. This is simple stuff. You want the more complicated stuff. I'll skip over that. Right, these are other functions that I do not teach, but could teach in future possible classes. Okay. So fork creates another process. What that means is that this line of printf will be run twice because there'll be two processes. And fork, since at the point of the fork, what happens is when the fork happens is that every variable created that this process knows about, the new process will also know about and will have the same value. So it'll also have its own a equal 9. Both of them will have a variable called a and equal to 9 at this point. In other words, the minute the fork happens, everything continues now from there down for both processes. So this variable a and this variable PID will be twice now. There'll be two of them. And fork will return to this PID 2 different values. So tell me, you guys, what 2 values will it return?
The parent and the child.
Be more precise. If you know, or somebody else.
One of them is going to be 0.
One of them is going to be 0, exactly. One of the PIDs will be 0. Which one?
The child?
Yes.
I mean, the child.
Yes. The parent's PID will be equal to what?
The PID of the child.
Exactly. Excellent. The PID of the child.
So when it says my value of PID, that's not right for either of them.
That's why I changed it. It used to say my PID is. that wouldn't be correct. But my value of PID, is just the name of the variable. Happens to be, it is a process ID. It's not my value for the variable PID is this. It's very, very misleading. Yes. It just means that, I could have called this stam, and then it'll be stam. My value of stam is,
While we're on the topic, what will get printed? Only the value of the PID of the child, or will
Well-
there also be a 0 printed? Because that's
I'm
what's a little
busy
bit-
going.
somebody want to answer? I like to have a chavruta here, so I'd like to have you guys answer.
It will be both. There will
Zero.
be 2 lines. One will have a 0 and one will be the actual PID.
Exactly.
And the
Exactly.
order.
And
Is
the
there-
PID of the child, the PID of the parent will never be printed.
Mhm. So only print.
It'll
The
print
child.
0. The parent will print 0, and the
Mhm.
child will print the child will print 0, and the parent will print the process ID of the child.
Okay, I understand. Okay.
Here's another example. These are all very simple examples. We're going to use more complicated examples of fork. Here I just differentiate. Once I've established that I can do this, so now I can, based on this PID, I can do an if. If PID, I can do the same program, but now I insert PID equals 0. If it's equal to 0, then I'm the son, else I'm the father. So I can use that property of the fork function to separate the code in my program between the things that are done by the father and things that are done by the son. And then we had this very complicated example, which I think I wrote for you guys in the previous class, but basically it's going to print, it's going to be 4 processes because there's a fork and a fork. So this fork is going to make 2, and then each of those 2 is going to run fork. So that
Why
means
does fork make 2?
the fork makes 2 processes, the parent and the
The
child.
parent and the child, yeah.
Then the parent's going to come over here and run this fork. So now the parent will have now at this point made 2 children, plus there's the parent, that's 3. But the child will also come over here and run this command, and he'll make a child. So the first child will have a child, and the parent will have 2 children. So that's a total of 4.
Wait, so the parent makes 2 children, and then
And one of his children makes another child.
Okay.
So that's 5. That's 4 processes.
I suppose maybe it's part of Daniel's question, but is whatever the main, let's say the main process that's running until the first fork, does that continue as the parent, or is that process somehow terminated and then we just consider it as 2 new processes?
No. You don't kill 2 processes, then create a new process. When you do fork, it's like dupe. It's like dupe Stein. It's like dupe 2. When you do dupe 2, you just make a duplicate of the previous one, of the previous file super. So let's do here. When you make fork, you make a duplicate of the current one. You don't get rid of the current one. You don't replace the current one.
Well, the
Right,
current
but
one
the
becomes the
main-
parent.
Right, it stays
The
as the
current
parent.
one we call him the parent, but you could also call him the original process. Right? It's just the original. It's just the same old process continuing. But it's quite indistinct. The 2 processes are quite indistinguishable one from the other. There is only a few features that are different. The parent, there's something called the parent process ID, the PPID. There's a function called get PPID. That will be different. That will return different values in the 2 processes, but pretty much otherwise they're identical. One is the child of the other, but they're both running the same code. So we said like this by will definitely get printed 4 times because there's 4 processes. But the hello will only get printed once, and we explained why, because it'll only be when this fork when the PID that's like sort of sitting here is 0, and the PID over here is 0. That's only once. But I'm not going to explain that now. I explained it once, not that important. Now we have a pipe. And let's go to the example. Now, the thing about a pipe is like this. A pipe is, the way I always explain it is that it's like a file that you can write to and read from. But the pipe is, I think in this example, I did a pipe without a fork. If you notice, it's just a pipe. And then somebody, the same guy, the process is writing to the pipe and then reading from the pipe. But this is really a more interesting example. And this is the typical way we do things with pipe and fork together, where we see that I make a pipe and then I do fork. And now what happens is the fork creates two children, or two processes, a child and a parent. And they both have the access to the single pipe that we created. Now you can say, right? So in other words, therefore one can write to the pipe and the other can read, and then the pipe can be a form of communication. Questions?
Yeah, I forget. How do we in the array that they're using, the parent and child they're reading and writing from, is it, I forget, we say that it reads from one spot in the array and writes to another?
Yeah, I'm going to explain that. Yeah, I'll explain that. But before I get there, I just want to explain another point, which is like this. This is the point that confuses people a lot, which is like, a lot of people say, well, wait a second, I did fork here. So now I have two pipes. Everything that's before gets doubled. I have two FDs, I have two PIDs, I have two CHs. Why don't I have two pipes?
If
Can
that were
anybody
the
answer?
case, you would have infinite forks, no?
No, I would
Because
just
then you
I
go to
can't-
the next line and you'd fork for this new
no, no,
PID.
no, 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 no.
Oh, okay, so the first
I don't
four,
mean to say that I run these lines again. I just mean to say at the moment that I'm here, at the moment that I'm after the fork, I have two programs and each of them have their own version of the variable CH that was created in the theoretical past. In other words, one program, let's call him the original program, he really ran these lines. The other program just had implanted in his memory by the alien overlords the memory that he had did these lines. But he's essentially here at the same point, but he has all these variables already created and already initialized, whatever would have happened. Because what we did was we copied all of the variables that existed in the father and we implanted them in the child. So he doesn't actually go back and run this because they need an infinite loop. But
is it a shallow copy or is it a deep copy? I assume they're just pointing to the same place.
no, it's a deep copy.
Oh, so they're really a deep copy, okay.
Yeah, it's a deep copy. He gets his own CH and his own.
What's CH being used here for?
I don't care, but the point is,
It's just random.
I'm just,
But
no,
it
it is
knows
being
not
used.
to.
It's
Since we
used
use
over
pipe.
here. It's used over here. But I'm just saying, if the child would change CH over here, the
Yeah,
parent
it's
would have.
different than the parent.
It's a different CH than the parent. All the variables are duplicate without going and executing all the lines that before. We just take the results. We just take the results of all those lines. In the end of the day, all those lines, all they did was define and perhaps change variable values, right? I mean, think about it. A function can run as many lines as you want. At the end of the day, here I am at the current line number. At this current line number, I've got a certain set of variables with their values, and I don't care how I got here. So the new child has all that set of variables with all those values.
Besides pipe, since we did pipe.
Why not so that was my question I started with. Why not the pipe?
I don't know, because it specifies it to put it in some place in memory that says don't make a duplicate of this.
Well, let's say like this. What is the pipe? Is it a variable?
Nah. Basically it is, but it's the share variable.
Somebody else want to answer differently from Daniel?
I'll answer
Everybody
the
agree with
opposite
Daniel?
of what Daniel said, but I actually also don't know the answer.
Anybody else want to attempt an answer?
The variable have to be a private.
I mean, I want somebody else to attempt the answer, even if you're wrong. You won't lose any points for being wrong.
You only lose face value.
You lose saving face, yes. All right, I assume that if you didn't say anything, you're either have drunk too many beers or vodkas, or you don't know. So I'll explain why.
Both resulting in a failing grade eventually, like on the test.
If you would continue doing that, yes. Daniel, you left. Okay. Suppose everybody else left too. I just don't see them. So the answer is, what's the answer? The answer is that the pipe is not a variable. It's just not a variable. Obviously, it's not a variable. What is it, an int? It's not a char. What is it? It's not a variable. I didn't declare it as a variable. I ran a function called pipe. I don't see any variable called pipe. I see a variable called FD. So guess what? FD is duplicated. There are two versions of FD. But what is FD? FD is a file descriptor. It's pointing to what? Well, by running the pipe command, I say point to the pipe. So there's this pipe out there in the mind of the computer. And I've got an FD pointing to it. So even though the FD is now another FD gets created, the pipe is still in the mind of the computer, or in another way, a more accurate way of saying it, the pipe is a resource is an operating system resource. And I can say it like this: resources do not get duplicated on a fork. Only variables. Daniel, I see, now I understand. Daniel went and got a beer.
He said get a beer.
I said get a beer. Did everybody get a beer? You're 18 and you're in Israel, so you're over 18.
If we don't answer, you can assume that we all went and got a beer.
Okay.
Either you can get a beer on campus.
Actually, all this talk of beer, I'm gonna get a whiskey, I think. In a little kiddish cup. Whiskey is the staff of life, no? My brother says if you're sick, you should drink whiskey. It'll make you, either it'll cure you or it won't. And if it doesn't, even if it doesn't, it'll feel better. So no, it's just I've been talking a lot, even though I didn't talk actually for a long time, but I feel like I've been talking a lot today. Talking about this semester. So where are we? So the resources, so let's remember it like this: the resources do not get duplicated, only the variables get duplicated. So PID is a variable, it gets duplicated. There's two PIDs and there's two FDs. That's the more important one. The FD gets duplicated. But the FD is just, now you can think about it if you want to use Yona's terminology. The resources are a shallow copy. In other words, we don't actually make a new resource. It would be absurd if you think about it, because a file is also a resource. We didn't learn, but there's something called shared memory. You can create shared memory. Shared memory is a resource. It's not going to be duplicated just because you forked your program. What will be duplicated is all the file handles to those shared memories, those files, and those pipes. But pipes, shared memory, and files are all system resources. Fork doesn't touch them. Only touches the variables of the program. They get duplicated. So at the minute we did a fork, we have a singular pipe, but two pointers to it. So in your homework of making the multiple pipe shell, what you had to do was create enough pipes for every pipe. Basically, you had to create one pipe for every pipe that the user typed on the command line. And then you're going to use those pipes for the various processes to communicate with. So what do I do here? At this point, when I'm in the child, there's only one pipe, but there's two FDs. So, and here it gets a little bit confusing, because notice that I do close FD0, close FD1. So that means that you might say the pipe is totally closed off. So why do I go over here in the father and also do close FD1? and close FD0? Can somebody explain that to me? I'm teaching, by the way, in a different way, if you notice. I'm teaching by asking questions because you've already learned this, and I want to extract it from you because I think you'll retain it better if you attempt to answer these questions, even if you don't answer correctly. So my question again, why is the child closing FD and FD0 and FD1, both sides of the pipe? And also the father is closing both sides of the pipe. It's already closed. Why are both of them closing it? I'll give you a hint. The answer is because close is a misnomer. What would be a better name for close? Or answer the question as it was.
Well, I mean, so the fork duplicated it. So no one
Duplicated
closing
what?
it.
Wait, don't say it.
The fork duplicated the pipe.
No, it didn't. I just spent 10 minutes explaining that it didn't.
It did duplicate FD, which is the thing that we had passed into the pipe.
Reference to a resource.
But thank you, Eliezer, or Ellie, for attempting to answer that, because that's what you should be doing. But
You need to close it so you know you can read or write to it.
no, that I don't care about that.
Close tells you that you can run the next.
Yeah, that's not an answer to my question either, Daniel. My question is, why close it twice? I already closed it. It's like closing the barn, closing the barn door before, twice, before the horse ran out and also after the horse ran out. Well, it's already closed. You can't close it twice. Why do I close the 0 side? The 0 side, remember, is the read side, and the 1 is the write side. I always get confused, but it's
You close both sides so that
I close both sides. Forget about why I do that. But why do I do it twice? Why does the child do it and the parent do it if there's only one pipe? I close the door on
writing at the same time.
No.
No.
What'd you say? What'd you say? The same
Closing
time?
it. You're closing it twice so that they both don't. You
No,
don't.
so I'll tell you like this: closing is a misnomer. What does closing actually do? What does it actually do? What does closing a file actually do? What it does is it frees up the file descriptor so that I can reuse that file descriptor for some other file. I mean, what does it mean to close a file? I am no longer accessing that file. I no longer have a file descriptor to that file. But
the child is getting rid of its access to this file descriptor.
Exactly. He's removing from himself access. That does not have any effect on the pipe itself. Only when it's kind of like, well, it's actually like a hard link. Remember we talked about hard links? A hard link is when I have multiple pointers to, it's kind of like a hard link. When I have multiple pointers to the same file. And what happens is like this: I can delete one of the file. I can delete one of the set of pointers. The file.
Isn't that a soft link? Wouldn't a hard link be like they're both like the same thing?
I think the opposite. Soft link seems to me like they're both it's like shallow and deep copy. That's how I've translated it up until now. I believe the soft link.
No, a hard link means that you see either kind of link changes to one will be seen in the other. So therefore, there's only one file really. There's only one file really. But when I do ls, I'll see it as though there are two files if it's a hard link. But any changes to one will be affected to the other. The difference is only like this, that if I delete the original file and I have a soft link to it, the soft link will be broken and will tell me broken link will no longer
and a hard link is.
And a hard link won't, because what's basically it's saying is everybody is an equal master of this file. Everyone is that's what a hard link is. Everybody is an equal master of this file. So as long as there's still one master left, the file will remain in existence. So even if I delete the original, the file will still be there because the second one that was a link was a hard link, and therefore he's considered like a master. And therefore, even though I deleted it, I didn't really delete it. So what does it mean to delete? All that it means to delete is to remove the count of how many people are pointing to it. Once the count is 0, then I really delete the file. But so it's the same thing over here. I've essentially got 2 pointers to each side of the pipe. So deleting one set of pointers doesn't yet get rid of the pipe because the other 2 are there. Only when I remove all the pointers to the pipe will the pipe actually go away. It's actually kind of like garbage collection.
So why is it good practice to close pipes immediately in the child process? You're supposed to like close all the pipes that you're not using. What's the point in that?
So it's not exactly like that. It's a little bit more subtle, and that is that notice that the child here closes just one and then writes to it and then closes the other. Closing the other is just a courtesy at the end. I mean, well, let's say he has to do that. He doesn't really have to do that necessarily, but what's going on here is that the child is writing to the pipe. Could be the child's reading from the pipe, but in this case, I did the child's writing to the pipe. And the rule is like this. The normal order of behavior of a pipe is first you write to it. Actually, I take it back. Wait, close the read side.
You're closing 0.
Wait, let me think for a second. The closing of the read side is kind of irrelevant, actually. This one is irrelevant. The truth is I didn't have to close this. I had to close this though, because the normal order is first you write to a pipe. And basically, if you want to do something that's not in the normal order, first you write to something, then you read from it. That's the normal. First you put water in the pipe, and then you take the water out of the pipe. You don't take the water out of the pipe before you put it into the pipe, right? So in this case, the child's doing the normal behavior. He's first writing and then never reading. But I just closed the read side for the hell of it. Didn't really have to do that. But what I did over here was that I wrote to the pipe and then I closed the right side to indicate that I'm no longer writing. But by this point now, I no longer have any pointers to the pipe. But the pipe is still in existence because the father has pointers to it. Now the father must do this line, which is close the right side. Why does he close the right side? Because he wants to do this weird thing, which is reading before he writes. He wants to drink the water out of the pipe, but he didn't put any water in it. But since there's only one pipe and he knows that somebody else put water in it, he wants to read anyway. So when you want to do that, when you want to read before you write, you've got to first close the right side so that the read will work. Let's say like that. You got to pretend like you finished writing. I'm finished writing. As I wrote nothing to the pipe, but I'm finished writing because it won't let me read until I announce to the world I'm finished writing. So I announced to the world I'm finished writing. Now I can go ahead and read. And it'll work. It'll read. It won't just sit there forever because there actually is something in the pipe because the child wrote it into the pipe. So now I can read. And then at the end, I close the read side, but I don't actually have to do that. The main thing that I have to do, notice I wrote here, if we don't do this close. In other words, on this particular one it's crucial. Even this one, I'm not sure if it's crucial. This one is crucial. So once we've finally done close of this side of the even before, once we've done this, now the pipe is gone. Now we've removed all the pointers to it, and now it'll finally disappear.
So now I have, I guess I have 2 questions on here. First of all, regarding the 0 and 1. Technically speaking, the child wrote to FD1, but then it's the parent is reading from FD0. So are these really just, I guess, like names, like indicators? Because
Well, remember, yes,
we
they
put
are
it in-
pointers to to the system resource. Like I said, it's a system resource. There's a system resource called a pipe, which you can think of as like a file. File is also a system resource. It's something external to the software.
So we didn't really
And
write into FD of 1. It's
you didn't
just
write into the FD of 1, after all, is just an integer. It's an FD of 1 is an integer. I didn't write hello father into an integer. That doesn't make
which,
sense.
yeah, that was my next question.
No, it's not. It's a file handle.
Why are they integers? Can they be characters? Can they be
No. They're
floating
file
point?
handles. Remember open. Maybe I should go back to open. Well, it's good we're having this discussion because these are some important concepts here. Open returns a FD, which is what? FD is an int. Open opens a file and gives me a number. It assigns a number. It's like if I would
It's like a
label,
function which
like
returns
if
a
I would
number.
label all of my books with a different Dewey Decimal number, you know, and the book is the book. That's something external. The FD is just the identification number for the book. So it's an int. So when I say write to, where are we? When I say write to this FD0, which is a single int, it's a single int, right? It's a particular member of this array, but it's a single int. I'm saying write to the thing, to the file that file pointer points to. Not technically, it's not a file pointer, it's called a file descriptor.
Could I also add, instead of FD of 2, could I use 3 or 4? What's with the number 2 specifically? Is it because there's 2 processes? Or is it because of the read-write property?
I mean, this 2 over here?
Yeah, I'm just confused. Like we could do
No, pipe
currently
always
it's just
pipe requires a pointer to
an array of 2.
an array of 2 integers. Yeah.
Or maybe it could just be FD1 and FD2, and we'd be able to use.
No, it needs to be a
another one.
pointer.
Yeah, it looks like a point. Okay.
It's defined. Look at pipe. Look what it says here. It takes not even a pointer, a hard to find array of size 2. That's its parameter. That is its parameter type. An int pointer, an int array of 2. That's it. I mean, you could try making an int array of 4 and passing it, and it'll just use the first 2. It'll give you a warning that you're passing something of the wrong type. Or you could cast it or whatever. This is a const. This is a const integer. You could screw around. You could even create, like, in your homework, you could create an int array of, like, 100, and then each time give it the next 2. Give it a pointer to, increment your pointer. Whatever, you can do all kinds of crazy things. But I'm just doing the most normal way possible. It must be a file descriptor it must be an integer, an array of 2 elements. And that's what I give it. In other words, it's 2 empty integers. I pass the pipe 2 empty integers. By the time the pipe returns, those integers are no longer empty. They have values. What values? Various numbers, 2 numbers from which represent pointers to the files. I don't know. I know what I'm saying.
Yeah, I got it. That was a fantastic explanation. I know.
Okay.
Quite confident about this topic.
Okay. Ellie, you have a question? Eliezer.
No.
Jacobson. No, Jacobs. So let's go straight to dupe 2. And here I want to put everything together now. I mean, not everything, but some bunch of things. Here's our pipe. Here's our fork. Now we have 2 processes. Each one has a PD. Each one essentially, I'm visualizing like this pipe there, and I'm visualizing pointers pointing to it, and I'm visualizing 2 at the top and 2 at the bottom. There's 2 points, and each one is a PD of a different program, different process. If it's a child, then I take his PD and I say, close the read side. Now this is not necessary actually. But like I said, because I'm going to write first. Here I write to the pipe. Now this looks like printf hello. You would say, no, that's not writing to the pipe, that's writing to the screen. Why is it actually writing to the pipe? Somebody tell me. No? I'm writing to the pipe. I guess you guys drank too many beers. Drink a Coke now. Maybe Coke originally had cocaine in it, right?
Well, yeah. He was trying to wean himself off morphine.
Yeah. Well, when they originally invented heroin, they thought it was the cure, the perfect thing. They thought it was the perfect drug. It was marketed as the perfect drug.
Still is the perfect thing.
Yeah, it probably is. But John Lennon, weaned himself off it. Heroin
Lennon was shot.
was a better form of morphine. And it's funny, when somebody is dying and they give them morphine because they just figure they're in pain, I don't know why they don't give them heroin. They give them morphine. They should give them heroin. When I'm dying, yeah, but if you're going to die in 3 days, in a week, when people are at their last week of life, they're on life support machines, they're never going to recover. That's it. They give them, or even if they're not on life support, they give them morphine.
While they're in hospice.
If they're in hospice, they're not on life support, and they give them morphine. And they even give you a little vial of morphine to inject, and you inject morphine. I don't know why they don't give them heroin. It'd be a lot more fun. Maybe the person wouldn't die. He would enjoy that heroin so much, he would just keep wanting to live. When I'm in that state, I want to have heroin and cocaine together. That's called, what is it called? Highballing or something? I don't know.
No idea, but I know what you're talking about.
That's how John Belushi died. That's how a lot of people died. Because the thing is like this, the heroin lowers your heart rate. And it can kill you because it lowers your heart rate until it stops.
We got like a tombstone. He lived as he died, or he died as he lived, whichever order.
Well, anyway, wait a second. The heroin lowers your heart rate. So if you can't take too much. But because it'll kill you. But if you take cocaine raises your heart rate. So if you want to take more cocaine, more heroin, you just take a little bit of cocaine with it. And then you keep on raising the cocaine as you raise the heroin. Now this is very dangerous because what happens is that the heroin, I forget which one of them, but one of them runs out of your bloodstream faster than the other. So what can happen is, let's say, I don't remember which one, let's say the cocaine goes out of your system faster. All of a sudden the cocaine finishes and now your heart rate is nothing to keep it up and the heroin kills you. So it's not enough that you balance it right. You even have to maintain the rate of cocaine. And I mean, unless you have like a professional anesthesiologist next to you, you're going to kill yourself. And that's what happens to these people.
That's why they get paid so much, because there's a fine line between.
Yeah, because if they wouldn't get paid enough, all these rich Hollywood people would hire them to help them manage their drug addictions. We got to keep
I guess if it was my last week, I would try to get a really specialized anesthesiologist. I think that's
That's
a
a
good.
trick. Who knows how to balance the cocaine and the heroin? Yeah, I mean, it's highly illegal, I have to say. For some reason, morphine is legal and heroin is illegal. I mean, with a you can't get a prescription for heroin. Just you can't. Anyway,
I must
that-
admit this class has been the most, I feel like, informative. I've learned like quite a lot of like throughout this course. It's been a very
you're saying not particularly computers, but just in general.
computers and in general. I feel like there was a lot of information, a lot of things. Whereas
All
other
right.
classes maybe more specific. Just wanna let you
Yeah,
know.
well, if you'd like, I can discuss ancient Israeli architecture or the 6-Day War or the Yom Kippur War. I'm an expert on both of those subjects. Anyway, but I don't want to discuss
Our course is missing like 0.5 credits in order to graduate. So if that could be a 0.5
Really?
credit, yeah, we're working on it. But if that could be a 0.5,
How is it 0.5?
because we get to what's the number? What not
There's a half a credit. That's called a half.
Yeah, yeah.
120 to graduate.
Where we have 119.5 if things
That's
go according.
fine. You'll graduate.
Well, I
See-
mean, with the half, obviously.
You need another
No,
half.
they'll let you graduate with a 19.5.
Anyway, so is this clear now? Why is why is this hello user printing to the not printing to the screen? Sorry, I feel like I lose half the class when I start discussing, non-relevant topics, but we're back to a relevant topic. So come back, whoever dozed off. Why is this hello user not printing to the screen? I'm saying it's printing to the pipe. Who can tell me?
It's using the one for instead of the whatever the stream to the screen. It's using the one for the pipe.
Yes, that is correct. Not said in the best possible way, but
Well, you can say it more elegantly for the class.
So while it's best practice never to believe comments because comments lie, in this particular comment, it implies that standard out is how you use
what's standard out?
just printing to screen.
What number
Standard.
is standard out? When I say what's standard out, you should say
One.
You should say 1, or you should say the screen.
Standard error is 2.
Standard error is 2, and what's 0?
Standard in.
I think standard error.
No, standard error
Nah,
was 2.
error 2.
It says standard error is 2.
0 would be
Standard
the
in.
keyboard.
standard in, yeah.
So what do I do? What is this dupe 2 doing here? It's duplicating the PD1. What is PD1? PD1 is by the way, it took me years to figure out the best way to explain this. I would use it and understand what it's doing but not be able to really explain it. And I have a really good explanation for it though. So PD1 is the right side of the pipe.
It's like going to the parent, right?
Well, pipe. It doesn't matter whether this line.
Because PD is what's getting passed into the pipe. 0 is the child. So if PD1 would be the parent. So it's
No. The 1 and the 0 have nothing to do with the parent.
Takes years, Ronnie. Takes years to get a good explanation. You can't just come up with a good explanation off the cuff. Like, come on.
Yes. Well, no, but
I'm just trying to understand. I'm not.
Yeah. Don't criticize your friends here. Everybody, we're all brothers here.
Right, I'm sorry, Ronnie.
The PD1 is the right side of the pipe, whether I'm the child or the parent or the child's child, doesn't matter. The PD1 is always the right side of the pipe, the side in which I write to the pipe. And what I'm saying is create a new file descriptor with the value 1 and make it point to the right side of the pipe. So if I had 3 pointers to, if I had 2 pointers to that, remember that visualization of the pipe here, and the 2 pointers pointing to it. Now I got a 3rd pointer pointing to it. What's that pointer? That's 1, but that's only in the child. I only did that in the child because this is only the code. This is the code of the child. In the code of the child, I said 1 should point to the right side of the pipe. So now, if I happen to know how printf works, I happen to know that printf is hard coded to write always to 1. Standard out. So printf is busy writing to 1. So he'll write hello user to 1. He blindly and incorrectly thinks that that's going to go to the screen because 1 is the screen. He doesn't know that previously I changed it so that 1 is no longer the screen, but is actually a duplicate pointer to the right side of the pipe.
He's
I have
been
a question. I have a question about that.
Yeah.
When does 1 get set back to be standard out?
Never.
After
In this
break? Oh,
What?
never?
In this program, never.
How would you
Remember-
set up the standard out
I do
again?
actually have a slide where I show how to do that, but it's not important. It's not important because this child is going to die, and I don't care anymore. He's finished. He's done his job. He wrote hello to the pipe, and then I don't even need this close. He'll just break, and there's nothing left of the program, so he'll end. And once he ends, all of his pointers are deleted. Everything is closed, essentially. Everything that he could have closed gets closed. So, yes, I've lost the ability to write to the screen at this point. I could regain it, but it's irrelevant. But it's important. That question is an excellent question because it means you understand what's going on here. I no longer can write to the screen. I'm writing that Y is going to go. I could write to the screen actually by 2, because 2 still points to the screen. 2 is standard error, and he also points to the screen. For example, I could do dupe 2, 1 after this. That would get it back, right? If I would, after hello, print hello, which would go to the pipe, I could then immediately do dupe 2, 1, which would mean now make 1 point to whatever 2 is pointing to. Well, 2 is pointing to the screen. I never changed that. So 1 will also point to the screen now. So that would be a simple way to get
do
it
like a swap, perhaps. You do some sort of swap between the standard in, standard
I just do
error,
like
and
this.
standard out, so you can give them all back to the norm to get them all back to normal.
No, just do dupe, right, exactly. Dupe 2, 2, 1.
But wouldn't that set it to standard error? Like standard
What happened to standard error?
I didn't change it. I duplicated it. I didn't change. Dupe 2 is still where it was. Dupe 2 is like copy, CP. Copy A, B. What does that copy A, B mean? It means B is now an identical copy of A. A is still A.
So we should save 1 first using some sort of mechanism.
I didn't save it.
Wait,
It should be.
That's the question though. If we're duplicating it, if
We
we're
want to get everything back to the way it was before.
Well, I just did that. That's exactly what I just did.
But
But
now
It's irrelevant. You know, reset 1.
the way we see it, this is just taking standard error and using that instead of using standard out. But that's still not standard.
No, standard error is just a number, and it's pointing to
Oh.
something. It's pointing to the screen. What do I care whether 2 is pointing to the screen, 1 is pointing to the screen, 7 is
Right.
pointing to the screen? I
But
can have
this-
lots of numbers pointing to the screen.
This could still be dangerous though, because what if we have our standard error set to go to a file, to go to some log file, and we don't want to.
Well, you're the programmer, buddy. You know, this is the program. I see the whole program right in front of me, and I see that I never changed 2.
Right.
If
No,
I
I get-
oh, you're asking like this. You're saying,
I'm saying, like,
Mr. Danzig, this is not a good solution because because
here it works
because
because
Yeah,
potentially
but Professor Danzig.
Professor Honorable Danzig, you have not given me a sufficiently logical answer, because I could have a theoretical case where I lose 2 and 1, and then what would I do? All right, you're asking like Tosas's question, and that's what I have a slide for later on. I see you want to see it, so I'll show you. Where is it? I have it somewhere. Hmm. No, I didn't do it. Where is it? Wait, find. Here. Here's how you do it. Open dev tty write only. That dev tty is the screen. Use the open command to create a new file descriptor, which is write only, because you only write to the screen. And now I have my FD back. And if I close one, if 1 is, let's say, closed, and 0 is in use, then when I do this, FD will automatically be 1. Because open always takes the lowest available free number. By closing 1, I've freed it up, it's available. And now when I do open, it automatically is going to assign 1 to FD. That's how I really get it back, if I've lost it entirely. I was just showing you, based on what you know already, how you can get it back.
Right. So here it works because 2 is already pointing. 2 is still pointing to the screen.
Exactly. 2 is still pointing to the screen.
Yeah,
So
using
now
the /dev/tty, can we assign other numbers to the screen?
Yeah.
Can I assign 17, for example?
Yes.
Oh, that's quite handy.
I mean, you have to do it. If you've totally lost access to the screen, you'll have to do it in 2 steps. First, you have to open the screen and like I showed you with the TTY, and then you'll get whatever number it wants to give you, like 13. And then you'll have to say dupe to 13, 17. And now you'll have 17 point, and then you can do close 13. And now 17 will be pointing to the screen.
Because we don't want that random number. I guess we can keep that random number if we want.
You could keep that random number. It doesn't do any harm. But yeah, I'm gonna say if you want Dafka 17, you can't force open to give you 17, but you can duplicate whatever it gives you to be 17. Now, if you notice, the duplicate has this several properties, because it also overwrites, if you think about it. Like here, I'm overwriting because 1 was at this point pointing to the pipe. And now I overwrote 1 and I'm saying it's a duplicate of 2 now. So it's now pointing to the screen. This is now irrelevant. This line is irrelevant. Actually, I should switch this. I mean, this is totally unnecessary because the program is about to end with this break. It's going to break and go to the end. So who cares? Why do I care about? I don't need to, even this is irrelevant. Even this close here is irrelevant. Once the program ends, it ends. Doesn't need to, you don't need to, it's not, it's just maybe, it is good to do. It is a good habit to do this kind of thing, especially the close, because you may later change it and decide to add some lines here, and you don't want it to get screwed up. So in other words, if you're forward thinking, you might just say, well, let's just be neat and tidy. Okay. So is there any questions on this program? Do you understand what this is doing?
So I have one small question about the close that you're doing.
Yeah.
Yeah. So are we only closing one side of the pipe here?
Exactly. We're only closing one side of the pipe. If you notice, we already closed the other side over here.
Right. Okay.
Close can only close a single file descriptor. Since the pipe has 2 file descriptors, pipe is very weird. Most files, every file has 1 file descriptor. Pipe is a two file descriptor pipe. Kind of weird. So I essentially wrote hello user. Then the parent process closes his right side, which he must do here, because he can't read without closing the right side. Remember the order, I've said this many times, the order is first you write to a pipe and then you read. First you put water into the tube and then you can drink the water. You can't drink it before you put the water in. So anytime you want to read, anyone needs to do something unnatural, like reading from the pipe, you have to first close the pipe because you're doing a weird thing. It's unnatural to read before you've written. It happens to work here because somebody else wrote to the pipe. Somebody else put water in the pipe so that I can drink from it. So first thing I do is I close it. Closing you can kind of think of as, it's kind of like the opposite of like Archimedes' principle with water. You know, if you hold water in a straw and then you release your finger from the top, the water will go down. So it's kind of like releasing your finger is closing the pipe. In that sense, it should be called opening, but that's what it is. You're essentially allowing the water to go out by saying close on the right side, saying I finished writing. Now, I do read here, and I say read from 0. But 0 in the previous line with this dupe 2, I made a copy of PD0, of the right side, of the read side, sorry, of the read side. No left. When I say right, I don't mean R-I-G-H-T, I mean W-R-I-T-E.
Okay.
If any, you have to go back now, everything you heard, every time I said right, I meant the right versus read, not right versus left.
I know, but I was also like, I knew that, but I was also thinking about like, just because 0 and 1 in sequence, 0 is on the left and then 1's on the right. That's also
Oh,
kind of.
okay. Anyway, so now I've closed the right side. Now I read from it, and I just read one character here. And I put it into character, I put the character on the screen, and I do a loop, whatever. That's pretty much it. Now what you would do in the Targil is that you would create a pipe, and then you would have the child. You see, when I do my execute, here, let's go down. We're kind of done here, but for the day, even though I started late, I'm going to end the regular time because really we're finished with the material. But here, if I execute, notice what I do here. I do a fork and then an execute. That means that the child is going to run this. Now, if I had a pipe created before the fork, and I wanted here, what if I do like this? Let's do. Yeah, okay. I think I could have copied the whole slide, but whatever. Oops. Here, let's make a new slide for future generations. Look what I can do here. I can say, here, let's call this, yeah, let's say like this, here. You gotta go. PI, PD, I don't know. I can do now pipe, PD. I now have a pipe. And now I want this execute instead of going to the screen, which is what it would normally do, right? Execute ls, going to go to the screen, right? That's if you just run the ls command, where does it go? To the screen. I'd like to have another parameter here that says something like PD, right? I'd like to have a parameter that said PD. I want to write this thing instead of the screen. I want to write it to PD, right? You understand my goal? Give me some
Am I right?
confirmation. What?
Wouldn't it be more correct to do PD at index 1? Because
Yeah,
we're right.
fine. Yes, yes, you're right. It should be like PD. It should be like that. Right. I'd like a new super version of exec that lets me write a file descriptor and it runs the command as usual, but instead of putting it in the screen, it puts it in this. Actually, by the way, that's how you should do the homework. Wow, that's a great idea. What a super idea. I just thought of that. That's a great idea. You could essentially write this function and just call execv with it, right? In other words, it'd be a wrapper function where in this function, call it my execv or my execv PD, and it'll call execv, but you'll give it this PD. But I can't, there's no function like this. Hey, before I was just talking to myself there. But let's say I want to do that, but I can't. There is no function like that. So what do I have to do? Very simple. This is going to print to the screen. So before I run it, what command will I write now to change it so it doesn't write to the screen? Here, I'll give you 10. I'll give you a clock 10 count. 10, 9, 8, 7.
What was the question?
Question was, what command should I write here to make it write to the pipe instead of the screen?
So you want to do dupe 2?
Thank you. Dupe 2. I want to copy
It's the PID or the fun.
PD
Sub 1.
of 1. Thank you. To what?
1.
To 1. So 1 should be a now when exec comes along, he has no idea what I've done before, the previous line. He just is a simple little fellow and comes along and says, oh, I've got to write this to the screen. How am I going to write to the screen? I'm going to write it to 1. And he has no idea that I've diverted 1 to the pipe. So now the result of this command will go into a pipe, which is exactly what you have to do in the homework. Now the father will have to read from that pipe. That's all. Let's call this diverting output of exec v to a pipe. I mean, I just added a pipe and then the dupe. I mean, I didn't fit. It's just I put it to the pipe and nobody's going to read from it. We should have like the father should now read from the pipe. You know, essentially, we should do something like this: read from the pipe into some kind of buffer of some size. I forget the order. Is it first buffer and then the size? First size. I think buffer and then size, and then like yeah. In other words, now if I read from the pipe, I'll get whatever he did. So that, I mean, I don't know why I'm doing that, but that's like a a way of doing stuff, a way of tricking execv to write to the pipe. All right, I will stop here. I think that actually is useful for your homework to understand what I just did there.